The CCS Optimizing C compiler is a powerful, simple-to-use tool for developing designs for microchip PIC microcontrollers and digital signal controllers. Let me show you how easy it is to go from C source code to a functioning MCU. In less than 5 minutes, we'll blink an LED. I'm going to start by clicking on the Windows 2007 folder icon to create a new source code file and save it in my project directory. A basic and key element of the CCS compiler is the device-specific header files that simplify the task of initializing the microcontroller. The header file is pulled into design by the include statement at the top of the source code file. The header file also tells the compiler to perform device-specific optimizations for the 16F877A, taking into account hardware details such as ROM and RAM size, stack size, and instruction queue. By performing optimization at the family and subfamily level, CCS is able to create much more efficient code than compilers that just perform generic optimizations for PIC devices. The use statement specifies the oscillator clock frequency. The value specified for the clock frequency will be used by the compiler later when built-in delay functions are called. I have assigned a constant named green LED to MCU pin A5 with this define statement. This program causes an LED to blink continuously at 1 second intervals. First, I'll create an infinite loop, then make 4 calls to CCS provided built-in functions to blink the LED on and off. The first function call turns the LED on. Next, I'll insert an inner delay loop of 1000 milliseconds. Now I'll turn the LED off and insert another 1000 millisecond delay. You can see how CCS provided built-in functions speed up software development by allowing you to concentrate on design functionality instead of having to become an MCU architecture expert. The delay millisecond function works by executing the precise number of instructions to cause the requested delay. The compiler uses the clock frequency and delay you specified to calculate the number of instructions for you, relieving you of that tedious and error-prone task. Placing your cursor on a function call and clicking F1 will bring up complete documentation on the function, including syntax, a detailed explanation of how the function works, usage examples, and even related functions. CCS provides over 300 built-in functions, including those for I/O, string handling, hardware-specific functions, even capacitive touch sensing, all with documentation and usage examples just a mouse click away. Notice that the C-Aware text editor makes it easy to create and read C source code. You're now on your way to creating your own library of functions. This source file can be called by any other program you write when you want to blink an LED. Let's compile the design. It looks like we have one or more errors in the design. The first error message is telling us that the device-specific header file in line 1 can't be opened. Device-specific header files have .h extensions, and I can see that I left it out of the file name by mistake. I'll correct the mistake and recompile the design. The log file displays the amount of ROM and RAM used, as well as any warning or error messages. The list file displays the assembly code generated by each line of C source code. You can see that the C code is much more compact and maintainable than code written in assembly. It's time to program the device. CCS offers several programming and debugging solutions to fit your needs, ranging from production and handheld programmers to powerful in-circuit debuggers. In this demo, I'm going to use our ICD-U64 debugger to program the device. Connect the ICD to the target board in your PC's USB port. Then, power up the target board. The IDE will call the CCS Load software to program the chip. CCS Load can also be used standalone without the compiler. You can see that the LED is blinking on and off at 1 second intervals. Let's double the blink rate. I'm going to change the delay value to 500 milliseconds, then recompile and reprogram the device. You can see that the LED is now blinking at half-second intervals. Now that you've seen how easy it is to begin designing with microchip PIC microcontrollers in the CCS Optimizing C compiler, what are you waiting for? The compiler is offered in flexible product configurations that start at just $50, enabling you to buy only what you need now and later add on additional family support and product features as you need them. Or choose from one of our complete development kits that include a compiler, development board, in-circuit debugger, and many other accessories starting at about $450. Download our demo software and try it for yourself.